Okay, good evening. Welcome to.
It's morning.
Good morning. Welcome to.
KidMath number 60.
KidMath number 60. All right, so in this one, this is going to be kind of a half more lecture one because this is what we've been talking about today, and there's a lot of stuff inside here, so I just want to go through it quick. We're going to find out here how to graph y equals x squared plus 4x minus 5. Okay.
All right.
So the type of equation has a 1 on the front, on the x squared, and then some other terms. Okay. So we've already learned in the last couple of days how to graph the simple equation y equals x squared. Okay, sort of looks like that. It's vertex there, right? And then we talked about two modifications to this. One would be something very simple like y equals x squared minus 3. So, oh, actually, grab a different color marker. Maybe we can do it here. See if that works.
That's okay.
Okay. What's x squared minus 3? Put it here. What's this going to look like before you draw it? Tell me what it's going to look like.
It's gonna get shifted down.
Okay, why is it going to get shifted down?
Because you have a minus 3. Because you have the numbers for this one.
Okay. Can you explain it in words a little better than that for me? Why does x squared minus 3 shift it down?
Well, for this one, you can have a chart. X squared. And let's just do minus 2.
Well, just do one example.
So minus 2 goes to 4.
Okay.
And then you get repeating numbers. That's symmetric.
Yeah, that's true. This will be symmetric, so when you get down to here to 2, you'll also get a 4.
Yeah, but then you have to add a minus. You have to subtract 3 from each of these numbers.
Okay, so for each number, now all you do is subtract 3. Okay, so for x squared minus 3, we're going to get 4 minus 3. Here we're going to get 4 minus 3, so it's going to be 1. So all the numbers get smaller, so what's the graph going to look like?
It's going to be something like this.
Okay.
Probably should have made it a little wider.
Put it here. Put it on this. Put it on this chart. What's this going to look like? Ah, interesting. Do you think they're ever going to intersect?
Probably not.
Why not?
Because they're the same shape. Like,
they're the same shape.
The first one and then the second one.
Okay. Actually, so this is a good topic. Maybe I'm going to change what we're going to talk about today. We're just going to talk about this. Okay. So y equals x squared looks like my purple graph. And you said x squared minus 3 is going to shift down all of these guys.
Okay, this one's a little better.
All right. And then when you drew it intersecting the graph.
They're going to be the same shape.
Right, so that's the thing. It's going to be exactly the same shape. It's going to be as if I picked up my original graph and slid it down. So what's it actually going to look like?
On here?
Yeah, on here. Draw it with your new blue.
It's probably something like that.
Okay.
Maybe a little wide.
All right, so maybe correct it and draw it one last time what you think it's going to look like. There you go. It's as if you took this original graph and just slid the whole thing down through. It's going to have its vertex here. There's going to be this similar looking gap the whole way through. See that? So shifting down on just one constant on the outside pulls the graph down. And if I made it plus 3, what would it do?
It would pull the graph up.
It would pull the graph up.
Like this, kind of.
Draw out what it's going to look like?
You just slide it up.
You just slide it up. See, it's very important. It's not steeper. It's not more smushed together. It's the same distance away the whole way through. So even this one you have drifting up at the end. See that?
Yeah.
It's going to be the same exact graph.
That was getting a little crowded with parabolas.
Yeah, it is. Okay, so this is actually pretty interesting. So this is just going from the geometry to the algebra, or the other way around. This is x squared. Here's x squared minus 3. Same shape, just shifted down. And then here's x squared plus 3, same shape, shifted up. pick up the graph, just shift it up, pick up the graph, just shift it down. What are some other kinds of shifts we can do with these graphs?
You can shift left and right.
Left and right too. So we're going to talk about that tomorrow. Okay?
Alright.
All right. Good job, sweetie. Good job.